emitter and base. So now we are connecting the bias voltage, that is the battery, between the emitter and base terminals. The emitter base should be forward bias. Emitter diode is forward bias and the collector diode should be reverse bias. Right? Now we can apply the battery, we can connect the battery between the emitter and base junctions or base terminals. In which direction the battery can be connecting to the emitter and base? Emitter is the negative terminal, so negative and false. And here reverse bias, negative, first one negative, positive, negative. Right? Next, so the batteries were connected to the input circuit as well as output circuit. This is the input circuit and this one is the output circuit. Now plus minus. Now we are drawing the input characteristics and the output characteristics. To draw the input means VI means volt ampere characteristics or VI characteristics. Okay, the graph between voltage and current. What is the input circuit? What is the input voltage and what is the output input current? Input current is emitter current, because of the emitter is the input terminal, and VEB, emitter base voltage, is the input voltage, and this is the bias voltage. Okay, now what is the ammeter direction? To measure the current through the emitter terminal or emitter base junction, we need to connect the one ammeter. Ammeter is the electronic component, to measuring component. Okay, to calculate the how much current is flowing through this junction, we are connecting the one ammeter in the series. Always you can connect the ammeter in the series direction and voltmeter in parallel. Okay, parallel to the way you are measuring the parameters. Okay, so now the emitter, how the current is flowing? The emitter current is flowing from emitter towards battery. Okay, so like that you can connect the ammeter. Next, voltmeter. The voltmeter direction is same as battery. In which direction you are connect the battery, the same direction you can connect the voltmeter. And similarly here also, what is the direction? Positive, negative. Here the what is the, it is okay, Gotala? Is okay now? Okay, so now the collector current direction is this, and base current is. So what is the total? What is the current in the? What is the current expression in this circuit? What is the current expression? Allow me to current directions. Collector current towards emitter, base current towards emitter. Then what is the equation for the current expression? Wait, so here also the current is IE is equal to IC plus I. The emitter current IE is equal to IC plus I. And in the working operation of the transistor also, here the 100 electrons and the 20% of electrons are recombined here, and 80% of electrons are reaching the collector region. So the total current constituted by the majority charge carriers of the emitter region only. Imagine the equation. So the total current I is equal to IC plus I. That is the current equation for the transistor in any configuration. There is a common emitter, common base, common collector. For the transistor, expression is common. For PNP transistor also. Next, that is the working connection diagram of common base configuration. Now we need to draw the input characteristics. This is the input circuit and the output circuit. If you want to draw the input characteristics, you can keep the output parameter should be constant. Okay, what are the output parameters? What are the output parameters? What is the voltage? Which voltage? Collector base voltage and collector current. So in this collector base voltage and collector current, the which parameter is changing the input characteristics? Listen, if you are understanding this concept, the remaining two configurations are is directly I will draw the characteristics. Okay. Now, okay. Here also same negative, sorry, positive, and here positive. Okay. Now, in this, if you are not applying the collector base voltage, listen carefully. What will be the current? How we are getting the current in the collector region? Because of the 80% of electrons, right? So this parameter is not changing the input characteristics. Input flow 80. If the emitter is having the 100% of electrons, in the 100%, the 80% of electrons are reaching the collector region. So that is not affecting the input characteristics. Now coming to the collector base region voltage, collector to base voltage. This is the collector. How we can increase the collector base voltage? By increasing the bias voltage. Which bias? Collector base bias. Okay. What is the meaning of this? What is the meaning of that arrow line? Battery rashanu, battery koka diagonal line rashi paina arrow ichcharu. What is the meaning of that? No. That is variable. We are changing the parameter. Okay, you can remember any symbol is there. This is the symbol. If you are drawing the line like there is the changing. Changing means upwards unte increasing, downwards unte decreasing. You can remember that. Downwards ever untado. We are doing always upwards there. So we are increasing the 0 to upwards. Okay. Now, so I am increasing. If you are increasing this, then what will happen in the collector base junction? The collector base junction. If you are increasing this voltage, ikkada emoutundi? Reverse bias. This reverse bias kada. This reverse bias valla what will happen in this junction? Increase. That increasing it like this. Okay, increase of. So while increasing the collector base junction, collector side increase avutunda, base side increase avutunda. Answer is correct. The increased junction width will penetrate. The penetrate into base junction. Why? Answer is correct. Base junction. Okay, why? Collector base మధ్యలో జంక్షన్ ఆ ఇంక్రీజ్ అయిన జంక్షన్ ఎందులో వెళ్తుంది అంటున్నాను బేస్ లో. దిస్ కాన్సెప్ట్ we are not studying the PN junction diode, do not have a concept రాలేదు. Why? Because the both p type and n type are equally doped. There is no difference. ఇక్కడ ఎంత అమౌంట్ అయితే డోపింగ్ ఉంటుందో ఇక్కడ కూడా సేమ్ అమౌంట్ ఆఫ్ డోపింగ్. ఆ ఇంక్రీజ్ జంక్షన్ ఇంక్రీజ్ అవుతే ఈక్వల్ గా డిస్ట్రిబ్యూట్ అవుతుంది ఇందులోకి ఇందులో. బట్ హియర్ the n type and collector and base are doped with different amount. So now the increased junction weightage can spread into the base or spread into the collector. Answer is the spread into the base. Why? అందులో ఎవరు స్ట్రాంగ్ బేసా కలెక్టరా why collector is the moderately doped or the collector is heavily doped with respect to base కన్నా ఎక్కువ డోపింగ్ అంటే మన దగ్గర ఏమున్నాయి సోల్యూట్స్ ఎక్కువ ఉన్నారు మన దగ్గర the charge carriers are more charge carriers more ఉంటే ఏమవుతుంది increase free space ఇస్తారా మనకి ఇస్తారా ఇవ్వరు so the base is the likely to the charge carriers are less అంటే what weaker so the increased junction width is spreading into the base region because of the base is the weaker region the charge carriers are very less okay now so ఈ width మొత్తం ఎందులోకి వచ్చిందమ్మా అంటే maximum part not almost 100% almost the 90% or 80% region is reaching into the base region okay so now we are keeping for the input characteristics you can keep BCB can be for example 0 volt BCB 0 now అది okay the next step వస్తుంది spread అయినంత ఎందుకు వాట్ దానివల్ల ఎఫెక్ట్ ఏంటి అనేది next first we are taking the 0 volt output voltage now we are varying input bias voltage అప్పుడు ఏమవుతుంది input bias voltage అంటే between which terminals emitter base now the emitter base is the forward bias or reverse bias forward bias so now that is same as PN junction diode any change simply we are keeping the collector base is the constant that is disturbed here so that means this junction this junction is acts as a PN junction diode under forward bias so we'll get the same characteristics what is the characteristics for example 0.7 we take the silicon okay 0.7 volt దగ్గర that will stop the conduction and we are getting on this constant voltage is VCB is equal to 0 volt now I will increase this VCB this is the VCB voltage now we can take the some 2 volts by varying this bias voltage I am keeping the collector base voltage is the 2 volt అప్పుడు ఏమవుతుంది we are increasing the reverse bias the junction width increases that increased junction width is penetrating into the base region now so we are applying the 2 volt the junction is increased that increase is penetrating into here now what is the resultant area of the base after applying the 2 volts for the VCB the resultant area తగ్గిదా పెరిగిదా తగ్గి so the resultant after applying the reverse voltage and the connected to base voltage the width of the base is decreased because the junction width is penetrating the base region because of that the width of the base is reduced now okay now you can remember that point now మళ్ళీ ఫస్ట్ నుంచి ఇది అయిపోయింది 0 పెట్టి మనం 0 వోల్ట్స్ నుంచి what is the ఇక్కడ ఏంటమ్మా VEB I in terms of milliamps lo untadi okay now milliamps now you can vary the again starts from 0 volts malli ikkada nunchi start cheyandi ఇది 0 నుంచి స్టార్ట్ చేయండి now ఏమవుతుంది అప్పుడు here the first initial case VCB is equal to 0 okay now VCB I am keeping 2 volts right what will happen in the input characteristics now in the 0 voltage what is the way normal width ఇది ఎంత ఉంటుందో ఇది కూడా అంతే ఉంటుంది right at the 0 volt so that starts at the 0.7 volt now increase చేసిన తర్వాత the base width decrease అయ్యింది Okay, now I am applying the input bias voltage. Now 0 volts dagara, how much time the emitter charge carriers will take how much time the emitter charge carrier will take the how much time the emitter charge carrier will travel from emitter to collector region at the 0 volts. Now, how much time that will take at now we are keeping the 0 volts. The BCB is the 0 volt, junction will decrease. Now, how much time this electron will take from emitter to collector region? Less or increase? Increase అవుతుందా? Less, because ఇంత ముందు ఆ ఎలక్ట్రాన్ ఇక్కడ నుంచి ఇక్కడికి ట్రావెల్ చేయాలి, బట్ ఇప్పుడు జస్ట్ ఇక్కడ నుంచి ఇక్కడికి ట్రావెల్ చేస్తే సరిపోతుంది కదా. సో అది ఎర్లీగా స్టార్ట్ అవుతుందా, కండక్షన్ లేట్ గా స్టార్ట్ అవుతుందా? Early. So if you are increasing this, if you are increasing this voltage, then if you are increasing the reverse bias voltage, the forward current, that is the input current, will start early because of the base width is decreased. This is called early modulation or the base width modulation. Early effect. Early అంటే fast. ముందే అనుకున్న దానికంటే that is effective before. So that effect is called the base width modulation or early effect. This is important for the objective type or 2 mark questions. What is the base width modulation? In common base configuration, the base width modulation is while increasing the reverse output voltage, the base width will get reduced, and due to the reduction of the base width, the electron travel from emitter to collector will take the less time. So that effect is called the base width modulation or early effect. Okay, now if you are increasing the BCB volt again 5 volts, then what will happen? That will BCB is equal to 5. That is the input characteristics, right? Now coming to output characteristics. BCB is equal to okay, design yes. Now coming to how we are drawing the input characteristics of the common base configuration. Output characteristics, output voltage will keep it constant, and we are varying the input bias voltage, and we are noting down the input voltage, that is the emitter to base voltage, and the emitter current. Then we are drawing the graph. So graph will get like this. And if you are increasing the reverse bias voltage, that is the collector to base voltage, the emitter diode will start conduction early. So that's why you are getting the before 0.7 only the diode starts conduction. That effect is called early effect or base width modulation. Okay, for the input characteristics. Now coming to the output characteristics. To monitor the output characteristics, which input parameter we need to keep constant? Anyone can answer? We can analyze quickly and we need the input draw చేయాలంటే output కామన్ పెట్టాం. ఎందుకు? అది base width అనేది ఎఫెక్ట్ అవుతుంది కాబట్టి. Base width is affecting due to the reverse bias voltage. So that's why we are keeping the output voltage constant. Now to monitor or to draw the output characteristics, the which input parameter we need to keep constant? Input voltage or input current? Huh? If you are keeping the input voltage constant, what will happen by applying the input voltage? Input voltage apply, what will happen? any more there is a forward bias. Forward bias అంటే ఏంటి? Junction ఏం ఉండదు. Direct electrons అని move అవుతాయి through the junction. Okay, now so there is no effect. ఎంత input voltage apply చేసినా we get the same current. Okay, now to draw the output characteristic, you can keep for the any characteristic for the three configurations. To draw the output characteristics, you can keep the input current constant. Why? Output of the current ఏంటమ్మా? Output of the current ఏంటి? Input దా లేక అది ఓన్ గా వస్తుందా? Input ఆ 80% electrons ఉన్నాయా? Due to that 80% of electrons only we are getting the current in the output circuit. Okay, now so you can to draw the output characteristic, you can keep input current constant. To draw the output characteristics, you can draw output voltage constant. Constant. We are not removing. We are keeping constant. The output characteristics also. For the output characteristics, we are keeping the input current constant. Okay. Now, first one, you can take input current 0 milliamps. Input current is 0 milliamps. What is the current expression? IE is equal to IC plus IB. Sometimes we are neglecting the IB also because very less current due to base. Due to base charge carries very less current. So that expression can be written as IE is approximately equal to IC. Now I am keeping IC is the constant. IE is constant, that is the 0 milliamp. Then what is the voltage and what about the output characteristics? Everything on board. I am keeping IE is equal to 0. How I am making the IE is equal to 0? By varying this bias voltage. అది వేరీ చేస్తూ ఎక్కడైతే 0 వస్తుందో అక్కడ దాన్ని ఈ బటన్ వదిలేస్తున్నాయి ఇంకా అంటే చేంజ్ చేయట్లేదు. Right? Now I am varying this. That is this. Varying. Then I am noting down collector to base voltage as well as collector current. Now the collector, if you are increasing this collector base voltage, what about the collector base voltage? Will increase or decrease? Parallel ఉన్నాయి ఇది. ఇక్కడ ఎంత వోల్టేజ్ ఉంటుందో ఆల్మోస్ట్ ఇక్కడ కూడా అంతే కనిపిస్తుంది. ఇక్కడ 5 volts సప్లై చేస్తే here you also get the 5 volts. Okay, if you are increasing this, the current voltage also will increase. Then what about the current? Output current. What is the expression? IE is approximately equal to IC. What is the value of IE? 0 milliamp. Then what will be the IC? But we'll get the some minute current. That current due to the charge carriers or minority charge carriers, similar to the PN junction diode. Okay. Now, so here we'll get what is the parameter here? VCB, IC. So here graph ఎలా ఉంటుంది చెప్పండి ఇప్పుడు VCB ఇంక్రీజ్ అవుతుంది IE మాత్రం కాన్స్టెంట్. దెన్ వాట్ ఇస్ ద గ్రాఫ్ ఎలా ఉంటుంది? ఎట్లా? ఇదేమో ఇలా ఉంది, ఇది ఇలా ఉంది, అది IE కాన్స్టెంట్ కదా. సో ఇఫ్ యు ఆర్ ఇంక్రీజింగ్ voltage will increase but the current is constant because IE is approximately equal to, so this value is IE is equal to 0 milliamp. Now you can keep IE is 5 milliamp. Then what is the graph? Five was so that means yes, IE is equal to 2 milliamp constant current, and then this I is equal to 5 ammeter. 5 is equal to 10. Or you can take the 50 milliamps. Okay, so that is the output characteristics. By getting the negative side here, anyone can tell me? ఇక్కడ నుంచి పాజిటివ్ వచ్చింది, పాజిటివ్ వోల్టేజ్, బట్ ఇక్కడ నెగిటివ్ వోల్టేజ్ కూడా డయోడ్ కండక్షన్ అయ్యింది. నెగిటివ్ వోల్టేజ్ అయితే ఏమవుతుంది? బట్ నెగిటివ్ వోల్టేజ్ ఏంటి? దిస్ డయోడ్ is acting as a forward bias. అంతేనా? Forward will get the some current na, so that's why it is called terminal. Okay, now this is the CB configuration and the CB configuration, the input and the output characteristics. Okay, now power. Okay, now the next configuration is common emitter configuration. If you are understanding the one configuration, the other two configurations are easy. So how in all configurations to draw the input characteristics, you can keep the output voltage whatever it is. Output voltage you can keep it constant. How we are keeping the output voltage constant? By varying the output bias voltage. This is the input bias voltage. Okay, now to draw the output characteristics, you can keep the input current. The input current is affecting the output characteristics. That's why we are keeping the output current is constant. How we are keeping the output current constant? Sorry, input current constant by varying bias voltage. This vary just to begin the voltage and the current power. That current you can fix in the ammeter. Then you can leave the button. Okay. Now coming to the output circuit, now you can vary the output voltage, note down VCB and IC, collector current. Okay, next. If you have any doubt, you can ask me. And don't copy blindly. You can understand the concept and note down. If you are noting down, if you are getting any doubt, you can ask me. Electronic concept is a completely concept based. Concept based. If you are understanding the concept, then you can write any answer for any question. Yeah. Next one, the CE configuration. Now you can try to draw the CE configuration circuit diagram. CE configuration. First, you can keep the transistor in. Right? Transistor in common emitter mode. The emitter terminal is common, and this is the collector terminal, and this is the base terminal. Now you can connect one ammeter to measure the input current, and then one voltmeter. Then you can apply the bias. This is the voltmeter, and simply here the one more ammeter and voltmeter, then bias voltage. This is the rough sketch. Simply, I kept the emitter is the common for input circuit as well as output circuit. Now, always for the normal working of the transistor, the emitter base junction should be forward bias. Based on that, you can apply the biasing voltage. Apply Janama. Emitter base should be forward bias. Now, what is the battery direction? Which transistor we are taking? NPN transistor. Emitter is the N type, P type, base is the P type, and the collector is N type. Now, what is the battery direction for the input side? The emitter base junction should be forward bias. Now tell me for this emitter negative positive negative positive. Now tell me this should be forward bias, and this one should be reverse bias. Connect the battery. Positive terminal to okay. Now negative. And here, what is the voltage direction? Voltmeter direction? Positive, negative. And here, how the current is moving? Emitter to base to emitter. Now the direction is positive, negative. And here ammeter, the current is negative, positive. And here battery, emitter, collector can take the reference. Collector can positive. And this voltage is collector to emitter voltage. And this voltage is base to emitter voltage. And this is the IB base current. And this is the collector current. Now you can draw the input characteristics. The input characteristics are what is the input parameters? Input current is IB, voltage is VEB, output is VCB, and the current is enough. Input characteristics. Is now to draw the input characteristics, which parameter we are keeping constant? The input characteristic is output current, output voltage is constant. Okay. Now, if you are keeping the output voltage constant, then what is the input characteristics? Input characteristics. Input junction is input junction. Emitter base junction only, right? So the input is the emitter base junction. Now the input base junction, emitter base junction is acts as a forward bias. So simply that is also gives the forward bias. Same normal. If you are keeping the output voltage 0 volts, then the input characteristics are same as PN junction diode under forward bias. At VCB is equal to 0 volt. Now you can increase the VC. VCB. Collector emitter voltage. Now you can keep the collector emitter voltage 2 volts. 2 volts. Then what will happen? This voltage we are keeping by increasing this reverse voltage. Here also same. Base width will increase. Base width will decrease. Same. The input characteristics of common base and common emitter are same. Now I will stop for the input characteristics. Then move to the output characteristics. For the output characteristics, which one we are keeping constant? Current. Which current? Constant. The input current is constant. Now if you are keeping input characteristic constant, then what is the output current? IB 0 10. How much current you are applying here, the same current will appear. Almost all 0. Almost all 0. So here 0 current. Now you can increase the current. It will increase. Then again you can increase. That will increase like this. So we are increasing the input current. Okay. Now, and one more topic we are having in our syllabus, that is the CE amplifier or RC coupled amplifier. The amplifier means it will strengthen the weak signals. I think you are using the TV setup box. Setup box. Antenna ఒక డిస్ట్రిబ్యూటర్ ఉంటారు ఆ డిస్ట్రిబ్యూటర్ నుంచి మధ్యలో చేస్తారు సో అది ఒక 2 కిలోమీటర్స్ ఉంది అనుకోండి ద డిస్ట్రిబ్యూటర్ అండ్ అవర్ హోమ్ in between, due to the longer distance, the signal will degrade. Okay. In that case, to strengthen the degraded signal, we are keeping the amplifiers. Again, that means amplified. For the set-top box also we are using the amplifiers, right? So the amplifier will amplify the signal, increase the signal levels. So in that case, we are using the transistor, that is the CE amplifier, the common emitter amplifier. Means that in the amplifier we are using the common emitter configuration. So thus amplifier is called common emitter amplifier or RC coupled amplifier. Okay, now you can remember this configuration. So now this. Now, yes. Okay, now see the each output characteristics are having the three different regions. Don't get confused. The transistor is having the three configurations. Now the output characteristics are having the three different regions. Okay. Now in the previous common base configuration, so we are keeping the input current constant. If the input current is constant, then what will be the output current? Also constant. But what is the constant value? Almost all 0. And in this case also, if you are keeping the common emitter configuration, the input current IB is the constant, the output current also 0, constant. Okay. So this means, what is the meaning of that the 0 current? This is, we are applying the 0 current. 0 milliamps. IB is equal to 0 milliamps. If you are applying the 0 milliamps, and what is the emitter base junction and what will be the collector base junction? That means in terms of forward or reverse bias. If you are applying the 0 volts at the input side, then what is the emitter base junction? Reverse. Forward some current, but there is no current. Almost all 0 current. Next, so that means the forward, the input diode also, the input diode means emitter diode also reverse bias. And already we kept output diode is constant. Already the output volt this collector base junction. Reverse bias. So now in this region, both emitter diode and collector diode both are reverse bias. If you apply the 0 input current, the input bias, that is the emitter diode and the collector diode, this junction and this junction both are in reverse bias. If both are in reverse bias, this circuit acts as a off switch. Off. Okay, so now this region is called cutoff region. CUTOFF, cutoff region. If both regions, that is the emitter diode and the input junction and the output junction, the both junctions are reverse bias, then that is called the cutoff region. Now here, ikkade undi cheppandamma. Ikkade undi ee madhyalo input diode ela undi, output diode ela undi, ante emitter diode ela undi, collector diode ela undi. Ikkada current increase ayinda. What is the meaning of that current increase? Input current eppudu increase avutundi? If the diode is forward bias. So now emitter in this region, the emitter diode is forward bias. And what about the other diode? We are increasing collector voltage and getting the collector current. What is the meaning of that? What is the collector base current voltage? Collector base voltage. Forward voltage or reverse voltage? Reverse voltage. So now in this region, the collector diode is reverse bias. And this region is called active region. Active region. Now coming to this. Here, this part. ఇక్కడ ఏమవుతుంది? ఇక్కడ diode. Now here the both are forward bias. That the emitter junction and the collector junction both are forward bias, and this region is called saturation region. Okay, the saturation region. Okay, the transistor configurations or transistor okay, now tell me the three regions. The first one is cutoff region and active region and saturation region. Okay, in cutoff region the both diodes are reverse bias, and in the active region the emitter diode is the forward bias and this one is reverse bias, and here the both are forward bias. The both are forward bias. Now based on these three regions, the active region, saturation region and the active region, the transistor cutoff region, active region, saturation region, the transistor can be used in different applications. The transistor can be used in different applications. The applications are, now you can see here, application is here. Now this can be acts as a off and this can be acts as a on. So if the transistor is working in cutoff region, then the transistor is acting as a off switch. The transistor is working in saturation region, the transistor is acting as a on switch. So based on this cutoff and saturation region, the transistor can be used as switch, on off switch. The one application is on off switch. And coming to the next region is the active region. If the transistor is the one junction is the forward bias, other junction is the reverse bias, then here the transistor can be used in shortcut rashanu amplifier. Okay, that is the amplifier. So based on these three regions, so we got the two applications. One is switch, other one is amplifier. Okay, the amplifier is nothing but it will strengthen the beat signals. మనకి ఏ level increase చేయాలంటో that amplifier will increase. Okay, no doubt. In most of the amplifiers we are using common emitter configuration. The most of the cases we are using this configuration only in amplifiers. That's a CE amplifier. The table also important for your 2 mark and 1 mark question. Okay. Now the next configuration is common collector, that is called CC configuration. doubt in this? So after this class, you have to answer any question. If you are not listening, you can't answer. You can't understand. Next, I will take just 5 minutes for the CC configuration. Then 5 minutes break. Again, you can come back. Break on that. But you can make punctual. Punctuality. Okay. Now the next configuration is CC configuration. Also, just you can draw the circuit. In CC configuration, what will be the common terminal? Collector is the common. The input terminal is emitter. The remaining operation is same. Same. ఇక్కడ ఏమవుతుంది? Emitter కాబట్టి పాజిటివ్. ఇది చేంజ్ ఆఫ్ డైరెక్షన్. This direction will change. Negative, positive. Now the CC configuration. Here this is the CC configuration. In CC configuration, the common terminal is collector. Input is base. Output is emitter. Next, here also change. It is same ఉంటుంది. ఇది construct using the construction diagram. This is common for all configurations. Okay. Now the input, output is same. Output characteristics of ఎందుకంటే ఇక్కడ white is same. ఇంత ముందు collector. ఇప్పుడు emitter. The IC is equal to almost approximately IE. That is IE is approximately equal to IC. So we get the same characteristics, but the input will change. Input characteristics. Here this is B, EC and the input characteristics. Why we are getting like that? VC equal to 4 volt తీసుకున్నప్పుడు గ్రాఫ్ ఇలా వచ్చింది. Why? ఇలా వచ్చింది. మనకి జనరల్ ఎలా వచ్చేది? ఇలా వస్తుంది. ఇప్పుడు ఇలా వచ్చింది. ఇక్కడ this voltage is larger or okay. Now ఈ వోల్టేజ్ ఎక్కువ ఉంటుందా? ఈ వోల్టేజ్ ఎక్కువ ఉంటుందమ్మా? ఏది ఎక్కువ ఉంటుంది ఇక్కడ? ఇదా ఇదా? ఇది ఎక్కువ ఉంటుంది. అంటే విత్ రెస్పెక్ట్ టు దిస్ వోల్టేజ్ దిస్ ఇస్ ద నెగటివ్ వోల్టేజ్ ఆర్ పాజిటివ్ వోల్టేజ్. అంటే ఇది 2 వోల్ట్ ఇది 4 వోల్ట్ కదా. విత్ రెస్పెక్ట్ టు 4 ద 2 ఇస్ ద నెగటివ్ ఆర్ పాజిటివ్? నెగటివ్ కదా. ఓకే, ఇక్కడ నెగటివ్ వోల్టేజ్ అప్లై చేసినప్పుడు ఇక్కడ ఏమవుతుంది? డయోడ్ స్టార్ట్స్ కండక్షన్ ఎర్లీ. ఇది ఇదేది? ఇది పాజిటివ్, ఇక్కడ వోల్టేజ్ ఏమంటున్నాను ఇప్పుడు? BCE వోల్టేజ్ 4 వోల్ట్స్ తీసుకున్నాం. 4 వోల్ట్స్ తీసుకున్నప్పుడు ఈ జంక్షన్ విడ్త్ ఎక్కువ ఉంటుందా తక్కువ ఉంటుందా? తగ్గుతుంది కదా, ఫార్వర్డ్ వోల్టేజ్ ఎక్కువ. బట్ హియర్ రివర్స్ వోల్టేజ్ ఎలా ఉంటుంది? రివర్స్ వోల్టేజ్ VPC is what is the diode VPC? Forward or reverse bias? Base collector junction. Collector base junction always reverse bias. Bias का वाला इच्छा. Okay. Now listen. Here ఇక్కడ 2 volts for example. ఇక్కడ 2 volts ఉంది, ఇక్కడ 6 volts ఉంది. అంటే ఇక్కడ 2 volts 6 volts. 2 volts ఉన్నప్పుడు రివర్స్ బయాస్ ఎక్కువ ఉంటుందా? 6 volts ఉన్నప్పుడు రివర్స్ బయాస్ ఎక్కువ ఉంటుందా? We are kept constant this output voltage, we kept constant. Output output voltage VC we kept constant. Now we are varying the input voltage, this bias voltage, and we are measuring the base to emitter. Okay, now base to collector voltage. Now in this ఇక్కడ 2 volts అప్లై చేశాము. 2 volts సిస్టంలో జంక్షన్ విడ్త్ ఎలా ఉంటుంది? రివర్స్ బయాస్ తక్కువ ఉంటుంది. తక్కువ ఉన్నప్పుడు కరెంట్ ఎలా ఫ్లో అవుతుంది? ఎక్కువ ఫ్లో అవుతుంది. సో దట్స్ వై వి ఆర్ గెటింగ్ ద గ్రాఫ్ లైన్. నౌ యు కెన్ ఇంక్రీజ్ దిస్ 6 volts ఇంక్రీజ్ చేసినప్పుడు ఏమవుతుంది? జంక్షన్ విడ్త్ ఇంక్రీజ్ అవుతుంది. అంటే ఈ వోల్టేజ్ ఇంక్రీజ్ అవుతుంది. VPE ఇంక్రీజ్ అవుతే conduction will less. The VPE less, the conduction more. That's why you are getting the more current here at this point. అంతేనా? ఇక్కడ ఈ పాయింట్ దగ్గర రివర్స్ బయాస్ తక్కువ ఉంటుంది కాబట్టి కరెంట్ ద ఎలక్ట్రాన్ చార్జ్ క్యారియర్స్ విల్ మూవ్ ఈజీలీ ఫ్రమ్ ది బేస్ టు కలెక్టర్ రీజియన్. If you are increasing this reverse voltage, the junction width increases, so the current is decreased. So that's why the graph is like that. That is the common collector configuration, the input and the output characteristics. Output characteristics of the common collector is same as common emitter configuration. Okay, note down and go for the 5 minutes break and come back. Then the interesting topic, our mobile phone charger adapter. Okay, మీరు adapter లేకుండా డైరెక్ట్ కనెక్ట్ చేయగలం మొబైల్ ఫోన్ కి. So now we need to understand the clear concept. What are the components are there in that adapter? ఒక డబ్బా ఉంటుందా? ఆ డబ్బాలో ఏమున్నాయి? We can understand later after this short break. Okay. Yes. Now, we are studying the PN junction diode formation, working operation, and PI characteristics. Right? Then the Zener diode drawback also we discussed the PN junction diode. To overcome that drawback, the next we are introducing the Zener diode. Okay. Now after the Zener diode, the PN junction diode and the Zener diode, the two terminal devices, both comes under diode family. Okay, next three terminal device, there is a transistor. How many terminals is the transistor? Three terminals. How many junctions? Two junctions. Now, how many, okay, in PN junction diode, the which charge carriers are constituting the current in PN junction diode? A charge carriers. The charge means minority charge carriers and majority charge carriers. The charge carriers? Majority charge carriers. The minority charge carriers are not involving to constitute the current in the PN junction diode as well as Zener diode. That is the single polarity. Okay. Now, coming to the transistor, how many polarities are constituting the current? One is the majority charge carriers of electron. That is the emitter. The majority charge carriers of emitter region. And what about the base region? Base and the collector. The base and the collector is reverse bias. That is also constituting the some current in the reverse charge. That is called the reverse saturation current. So in the reverse saturation current, which charge carriers are constituting the minority charge carriers? Okay. So now in the transistor, the two polarities are involved in the current conduction. That is majority charge carriers and minority charge carriers. So that's why the transistor is named as BJT. The transistor is named as BJT. BJT stands for bipolar junction transistor. Bipolar is bijunction. Bipolar means the two polarities, like the minority charge carrier, majority charge carrier. That is the positive ions and negative ions. And coming to the two junctions, the emitter base junction and the collector base junction. Two junctions are present in the transistor. So that's why the transistor is named as BJT, bipolar junction transistor. So under BJT only, NPN transistor, PNP transistor, the three different configurations. And one more transistor is there. You are not having in our syllabus. That is the field effect transistor. The BJT is the most noisy transistor. And that is the noisy transistor. And in the to make the integrated circuits, this is not the recommended transistor or recommended electronic component for the integrated circuit. That is the ICs. Usually name is chip, black chip. Okay. Now, so the next transistor is the FET. FET is the noiseless transistor. So the most of the ICs that concept only using. Okay. Now coming to applications. What are the applications of a transistor? The transistor can be used as switch. Second one, amplifiers, and that can be used in the computers and in other electronic circuits. Okay. Now coming to the applications of the diode. Based on this application, we are going to discuss the one application here. Okay. What is the first application of the diode? That is the Zener or PN junction diode primary application. Switch. The primary application is switch. And the second application, this can be important one, and we are going to discuss, that is the rectifier. The diode can be, which diode we are using? PN junction diode. Okay, later we can use the application of the Zener diode also in this concept only. Okay, now the switch and the rectifier. That switch and on off, like switchboard. Switchboard on a switch on just a current is flowing, the device will work. If the off, current will not flow, since that is the off. Okay. Now rectifier. The rectifier is the application of the PN junction diode. The rectifier is, it converts AC voltage into pulsating DC voltage, not DC, pulsating DC voltage. Now, what is the AC voltage? Alternating current. Now, what is the rating of the 6-volt power supply? What is the rating? AC stands for alternating. What is the rating? What is the rating? 230 volts. And that is the alternating current. That is also having the frequency. Frequency is a simple law. Okay, so you can everyone remember the usual homoplex power supply is 230 volts and 50 hertz according to the Indian standard. In American standard, there is a 60 volts. 60 volts we are not using here. There is a 50 volts. 50 hertz frequency units are hertz. So the 230 volts and 50 hertz. Now, so the 230 AC voltage we are converting to the pulsating DC voltage using rectifiers. Now, this rectifier application is in our mobile phone adapters. Okay, so now there is another application, and other application this can be used in computers and other electronic gadgets. Okay, the diode can be used in the major one is switch and the rectifier. Now, before getting the rectifier, I will draw the one circuit block diagram of DC power supply. The block diagram of DC power supply. Okay, now you can assume your mobile phone adapter. Where you are connecting the mobile phone adapter? Where you are connecting? Switchboard. Okay, so now you can take the input. And what is the rating? 230 volts, 50 hertz. How much output voltage you are getting at the output of the adapter? 5 volts. But what is the input voltage? 230 volts. So if you are converting the 230 volts into pulsating DC, how much DC voltage you will get? Same 230 volts, not 5. 230 volts. But our requirement is 5 volts, 5 to 10 volts. Now, so further, to decrease this 230 volts into lower voltage, we are using, I am not writing the full, step down transformer. We are using step down transformer. Step down transformer means it converts high AC voltage into low AC voltages. Any transformer, I think I know. So any transformer is either two windings, primary winding, secondary winding. If the primary windings are more and the secondary windings are less, that transformer is called step down transformer. And they can winding and that use the less voltage. So that transformer is called step down transformer. And another transformer is inputs are less, outputs are more, then that is called the step up. So step up is not required here. We need to reduce the 230 volts into 5 volts. Now we are using the not 5 volts, 9 volts step down transformer. For example, in the market also 9 volts transformers are available. Why I am in the 9 volts? You will understand later. Okay, now what is the output voltage here? What is the output voltage? 9. So now here at the input side, simply I will draw the. So here the voltage is high. For example, we can assume peak to peak voltage is the 230 volts or 230, right? Next, here the step down transformer with output is like this. Compare both. Reduce the amplitude. This is called the amplitude. So amplitude is reduced because of we are in the step down transformer. And this step down transformer output we are connecting to rectifier. We are not connecting the direct power supply to our mobile phone. So first we are using the step down transformer, then rectifier. Okay. Now what is the rectifier? Here the rectifier input is bidirectional voltage. That's the bidirectional voltage. So positive voltage. This is the positive half cycle. This is the negative half cycle. positive and negative. Okay, next, so the positive of cycle and negative of cycle. Now, after applying the rectifier, in this rectifier we are using the diode. How we are using the diode as a rectifier, we'll understand now. Now, so here we'll get this rectifier will convert the bidirectional voltage into unidirectional. That unidirection may be the positive of cycle or negative of cycle. Right? The positive of cycle or negative of cycle. Okay, now, so how much voltage will get here? Now, see here, so ripples this is ripples ripples so here, this is the pure AC voltage, and this one also pure AC voltage. Now, in this, we are having AC component as well as DC component. The output of the transistor, output of the rectifier, we are having the two components, that's the AC component as well as DC component. Our mobiles require the which voltage? DC or AC? AC. DC voltage. AC current burn the mobile. We are using the adapters. So adapter output voltage is the DC supply, not AC. So, but if you are connecting this rectifier output to directly your mobile phone, the mobile phone will get damaged, or any other electronic device will get damaged. We need to remove this AC part. To remove the AC part, we are using filters. We are using filter. Filterization water filter. Impurities pure water. So here also, what we require, what purpose we have the filter here? To get the DC. Now this filter is removing the AC part, and that will give only DC part. Right? So now here we are getting DC like this. Straight line. Straight line is number 0 frequency component is 0. Here the ripples the frequency alternating current. Alternating current electronic is there, that will damage. So we are converting this impure DC to pure DC using filters. Okay, now how much voltage? For example, in the voltage transformer 9 volts. So 9 volts DC we got. T time period is 0 if 0 straight line. Okay, now we got the pure DC voltage, but how much voltage? 9 volts. But how much voltage required to our mobile phone? 5 volts. Can use the regulators, voltage regulators. That voltage regulator, how much output voltage you require, you can use that voltage. For example, 6 volts out of 9 volts, you can use the GNR as the voltage regulator. If you want 5 volts, morning I told 7805 IC. 7805, that output IC gives the 5 volts supply. So in this voltage regulator, you can keep the 7805 IC, then you will get the 5 volt supply. Then you can connect to your mobile phone. If you are having the except your mobile phone, I think in thousands of don't connect this circuit. If you are anyone interested, you can design this circuit after this class, and you can try to give the any one electronic low cost electronic device that is damage money. Okay. Now, so here this will give the DC supply block diagram. So what are the components are there? This step down transformer. We are not going to study here this step down transformer. Simply we are using the step down transformer. Then rectifier. In this rectifiers, the different rectifiers are there. Half wave. Half wave technique. ఇందులో ఉన్న half మాత్రమే యూజ్ చేస్తున్నాం. Remaining half we are ignoring. That rectifier is called half wave rectifier. And another rectifier is full wave rectifier. In full wave rectifier, again the two types, full wave and bridge rectifier. in your syllabus you are having the bridge rectifier. Okay, and this full wave and bridge are both gives the full cycle, positive half cycle as well as the negative half cycle also. And coming to this filter, here in our syllabus the different filters are there. We are using C filter. The C stands for capacitor. The C filter, and then and the C filter, L filter, LC filter, and the CLC filter. So these many filters are there, but in our syllabus we are studying only C filter. And coming to the last one, regulator. Here we are using GNR as a voltage regulator. So these many topics are we are going to discuss. What first one? Operative full wave rectifier, in the bridge rectifier, then filter, then voltage regulator. The GNR circuit, simple circuit. Already we discussed the GNR diode. Once again we discuss the GNR, how the GNR is acting as a voltage regulator. Okay, what is the voltage input for the GNR voltage regulator? Filter output. What is the filter input value? Rectifier output. The rectifier input is step down transformer output. Okay. If you want to note down, you can note down. This is very important. దీంట్లోనే మొత్తం ఉంది. Next topics. The block diagram of DC power supply. Power supply. In the class. Okay, the block diagram of DC power supply. How many blocks are there? The 4 different blocks. In the 4 different blocks, we are going to study the 3 blocks. One is the rectifier, filter, regulator. Okay. Okay. Next, put a heading. Rectifiers. మీకు కాన్సెప్ట్ కావాలా యాజ్ పర్ సిలబస్ కావాలా? If you want concept, first I will explain the full wave rectifier, then I will go to the bridge rectifier. Then I will explain the paralleling, full wave as well as bridge rectifier. Now, put a heading, rectifier. What is the rectifier? It will convert AC voltage into pulsating DC voltage, not DC, pulsating DC voltage. So the different rectifiers are there: half wave, full wave, and bridge rectifier. The full wave rectifier full wave rectifier. In this full wave rectifier, we are using the transformer. That transformer is step down transformer. And here we are keeping some magnetic plates, parallel plates. Okay. The left side circuit is called primary circuit, and the second other side is called the secondary circuit of the transformer. The primary are called windings. How many windings? More windings compared to the secondary side. Okay. So now here we are applying input voltage, that is the VI 230 volts and 50 hertz. 230 volt and 50 hertz. Now coming to this, we are using the two diodes. The two diodes, and this is the zero terminal, and this is the positive, and this is the negative. Negative voltage. For example, positive 9 volts, here minus 9 volts. Right? Here minus 9, and then with respect to this, here positive, here negative, here positive, here positive, this is negative. Right? Next. Listen carefully, and here this waveform is like this, and this waveform is a negative, positive, positive, negative. right? And this diode is the D1 diode, and this diode is D2 diode. Okay. Now apply the input. This is the input. And this is the output. This value is the pi, 2 pi, 3 pi, 4 pi. If you want, no doubt you can, otherwise you no need to take the 0, 2 pi, 3 pi, 4 pi. That is easy concept. Okay. Now this input waveform we are applying to full wave rectifier. After getting this concept, you can understand this is the bridge rectifier. Okay. Now this transformer, how many input wires at the input side? Into time of wires? 2 wires. Output side? How many wires? 1, 2, 3. So that transformer is called step down center tapped transformer. Step down center tapped transformer. Okay. Now first apply the 0 to pi. This one apply this positive half cycle to first duration 0 to pi. Apply the D1 diode as well as D2 diode. What is the supply? Negative supply or positive supply? Positive supply. Now I can connect this positive supply to D1 diode. And positive, negative. What will be the D1 diode status? Forward or negative? Forward or reverse? This terminal diode. Positive terminal, negative terminal. Now, if the hello. Now the input waveform Vi. See the circuit or waveform. Now the positive of cycle, that means the 0 to pi duration cycle we are applying to D1 diode as well as the D2 diode. The 0 to pi, what is the voltage? The positive or negative? Positive voltage. That positive voltage we are connecting the D1 diode. The D1 diode to positive terminal. That is the anode terminal. Now, what is the status of the D diode? D1 diode? It is forward or reverse bias? Forward, forward. Positive, positive connected same of the next. Repel of the repel or negative. Wait. What is the wait? ఇక్కడ పాజిటివ్ ఉంది డయోడ్ పాజిటివ్ కనెక్ట్ చేస్తాం ఈ పాజిటివ్ ఏమవుతుంది ఇక్కడ ఉన్న పాజిటివ్ ని రిపెల్ చేస్తాం ఆ రిపెల్ చేసినప్పుడు ఆ హోల్ ఏమవుతుంది జంక్షన్ క్రాస్ అయి బయటికి వెళ్ళిపోతుంది జంక్షన్ క్రాస్ తో వాడితే మీనింగ్ జంక్షన్ లేదు అని జంక్షన్ లేదంటే ఇక్కడ ఫార్వర్డ్ బయాస్ సో సింప్లీ బ్లైండ్ యు కెన్ రిమెంబర్ ద పాజిటివ్ టర్మినల్ ఆఫ్ ద బ్యాటరీ and positive terminal of the diode if you are connecting then that is the forward bias. At same connect cheste forward bias, ulta connect cheste and positive to negative, negative positive connect that is the reverse bias. Okay, now the input voltage positive we are connecting to the D1 diode. D1 diode. Now what is the D1 diode status? Forward bias. Forward bias means that acts as a short circuit. Forward bias kada. So how much current is present here? The same current will be up here. Eppudu up here avutundi adi short circuit avutadi aa junction ellipoyi simply wire bond connection establish avutadi. So the total current can flow from this side to this side. So the output waveform is this. So which diode is giving this output? Which diode? D1 diode. Now we can write the D1 diode. So D1 R. Okay. Now coming to the same duration, the 0 to 5 only, that is the 0 to 5 to D2 diode. What will happen? This is the negative voltage we are connecting to D2 diode. D2 positive. What will happen? D2 reverse bias. So the D2 is off. The diode, I give the switch. Switch ఎప్పుడు అవుతుంది? ఫార్వర్డ్ బయాస్ ఉంటే స్విచ్, ఆన్ స్విచ్, రివర్స్ ఉంటే ఆఫ్ స్విచ్. ఆఫ్ అంటే open circuit. Okay. So now the first half cycle is over. Now coming to the second half. This. What is the second half? Negative or positive? Negative. So negative voltage will connect to the T1 diode. What will happen? T1 is reverse bias. Off. Next, coming to the same duration, D2 diode positive. So the D2 can conduct short circuit. So the D2 changes on only connect చేశాం కదా, అంటే ఇక్కడ నుంచి సప్లై ఇలా వెళ్తుంది, ఇక్కడ నుంచి వెళ్ళేది ఇలా వెళ్తుంది. Okay. Now, so if the negative half cycle, the 5 to 5 you are connecting, the second half also appear due to the negative, that is the D2 diode. Okay. Next you can connect similarly half wave rectifier ante em ledu, you can remove this part. appudu em avutundi, only half cycle maatrame work avutundi, negative half ki బంద్ ఉంటుంది, అంటే ఇది రాదు. That is the half wave rectifier. Okay. So this is the output of full wave rectifier. Now how many diodes we are using the full wave rectifier? Two diodes. Now coming the bridge rectifier. What is the bridge? The diodes are connected in bridge shape. Bridge ante camera color. Bridge shape. Okay. Now you can see, you can take the step down transformer. Okay, now you can see the bridge rectifier. How many diodes we are using here? 4 diodes. The bridge rectifier, 4 diodes. Okay. Now this is the ground terminal amount, and this one also ground. Okay. Ground along with this one. Okay. Now here, now I can take pi, 2 pi, 3 pi, 4 pi, 5 pi, and 6 pi, and so on up to infinity cycles. Now you can apply the positive half cycle to the bridge rectifier. Now this diode you can call as a D1, D2, D3, D4. Right? D1, D2, D3, D4. Now you can apply the ఇక్కడ ఇంకా ఇన్పుట్ ఇవ్వలేదు. 230 volts, 50 HZ. We are in the step down transformer. That step down transformer is converting the high voltage into low voltage. High voltage into low voltage. Now apply the first half cycle between the 0 to 5 period. Apply చేయండి ఇక్కడ. ఇక్కడ ఏముంటది? ఇక్కడ positive we are applying and here negative. అంతే కదా? Two terminals and one is the positive, other one is negative. Now what are the diodes are on state and what are the diodes are reverse bias, that is the off state. See the circuit. Forward bias అంటే ఏంటి? Positive to positive connect చేయాలి, negative to negative connect చేస్తే that is called the forward bias. Plus to minus, minus plus connect చేస్తే that is the reverse bias. Reverse bias means the diode is off, open circuit. Tell me. The diodes are D1, D2, D3, D4, 4 diodes. So in that 4 diodes, what are the diodes are reverse, what are the diodes are forward? D1 off, D1 forward, D3 forward. Next D2, D4 are reverse bias. Now after applying the 0 to pi cycle, the circuit should be closed circuit. ఎలా ఉండాలి? Closed circuit. So now okay, now ఇక్కడ చూడండి, positive D1 is forward bias, negative D3 diode is forward bias. Now ఇక్కడ positive కి negative ఉంది, so this is open circuit and this one is open circuit. Now you can check the circuit is the closed or open. ఇక్కడ చూడండి, ఇక్కడ చూడండి, ఇక్కడ స్టార్ట్ కండి, ఇలా రండి, ఇలా వస్తున్నాం, ఇలా వచ్చి ఇక్కడ దీని మీనింగ్ ఏంటి? కర్వ్ ఉంది అంటే దీనికి కనెక్షన్. Okay, now see here, we are coming like this. Ochindha? Closed ochindha? So the circuit is closed circuit. So the which half cycle will appear at the output side? This cycle, due to which diodes? D1 and D. So the output is will appear at the same, that is due to D1 and D. So during the first half cycle, the D1 and the D3 can conduct and will get the output. Now coming to next. D4, D2. Now we can apply the pi 2 to pi. Which cycle we are applying? Negative half. We are applying negative half. Right? Now, so here, right? Positive here, negative. Okay. Now it was it. Okay. Now during the negative half cycle, ఇక్కడ ఏంటి? Negative here, positive. ఇప్పుడు ఏమవుతుందమ్మా? Due to this negative terminal, negative terminal, D1 is off, the D1 is off, and here ఇక్కడ negative, ఇక్కడ positive, the D3 also. Okay, now now you can see the circuit is closed or open. The input close the. Now the input is appearing in the output side. Which output? First output and negative output. Listen carefully. ఇక్కడ ఏంటమ్మా ఏ సైకిల్ అప్లై చేస్తున్నాం ఏ సైకిల్ నెగటివ్ ఆఫ్ సైకిల్ ఓకే నెగటివ్ ఆఫ్ సైకిల్ ఇలా వస్తుంది ఎక్కడ ఇలా వచ్చింది ఓకే ఇలా వచ్చి దేనికి కనెక్ట్ అయింది నెగటివ్ ఆఫ్ సైకిల్ ఇదేంటి పాజిటివ్ ఇది నెగటివ్ సో నెగటివ్ దేనికి కనెక్ట్ అయింది పాజిటివ్ ఇక్కడ నెగటివ్ దేనికి కనెక్ట్ అవుతుంది సారీ ఇక్కడ ఏంటి పాజిటివ్ కదా ఇక్కడ ఉల్టా కదమ్మా అంటే ఇక్కడ నెగటివ్ ఉంటుంది ఇక్కడ పాజిటివ్ ఈ పాజిటివ్ దేనికి కనెక్ట్ అయింది చూడండి పాజిటివ్ టు పాజిటివ్ వచ్చిందా నెక్స్ట్ నెగటివ్ తీసుకోండి సో అవుట్పుట్ ఏమైంది పాజిటివ్ నెగటివ్ సో నెగటివ్ విల్ బికమ్ పాజిటివ్ డ్యూ టు the D2 diode and D4 diode and similarly for the next rest of the cycles also will get the same and during the positive of cycle the D1 D3 are on and D2 D4 are off. During the negative of cycle D2 and D4 are on and D3 D1 off and the remaining same 2 by 2 3 by and 3 by 2 4 will get the same. ఇది వన్ సైకిల్ అంటాము వన్ సైకిల్ పీరియడ్ ఎలా వచ్చినాయో నెక్స్ట్ సైకిల్ కూడా సేమ్ అలానే వస్తుంది ఓకే సో దిస్ ఈస్ ద వర్కింగ్ ఆపరేషన్ ఆఫ్ ద పిఎన్ జంక్షన్ సారీ bridge rectifier so how many diodes we are using how many diodes in the bridge rectifier two diodes which transformer we are using here center tap and here transformer is the normal transformer compared to this normal transformer this transformer cost is high. Finally, which one is costlier? Full wave or base? Full wave. ఎందుకంటే ఇక్కడ డయోడ్ కాస్ట్ తో కంపేర్ చేస్తే ట్రాన్స్ఫార్మర్ కాస్ట్ ఇస్ ద హై ఇదంతా 2 రూపీస్ 3 రూపీస్ ఉంటుంది ఈచ్ డయోడ్ బట్ ట్రాన్స్ఫార్మర్ 200 300 ఉంటుంది సో విచ్ వన్ ఇస్ కాస్ట్లియర్ దిస్ వన్ సో ద మోస్ట్ ఆఫ్ ద ఎలక్ట్రానిక్ సర్క్యూట్ అండ్ ఇన్ యువర్ సిలబస్ ఆల్సో యు ఆర్ హ్యావింగ్ bridge rectifier okay so the same content is enough for your syllabus. And here some parameters are there. That parameters we'll discuss and then one more is the filter. C filter, that's the filter and regulator we'll discuss. The only two topics we'll discuss in the next class. Okay? Last this is not about the class topic and so the explanation should come continue the same or any changes are required. So now this chapter is going to close and the next two concepts are different. Giving out resistor, capacitor, transistor. So the next two unit topics are completely different. You know, completely the concepts are different. Okay. That concepts are related to your branch, computer science branches.
tomorrow all day on the అందరూ అటెండ్ అవ్వాలి నేర్చుకోవాల్సిన హాస్టల్స్ కూడా మీకు వైవై వాయిస్ ఉన్నది హాస్టల్ వాళ్ళకి ఇప్పుడు 4:30 to 5:30 ఐసోలేటెడ్ క్లాస్ మీరు